Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, we're going to focus on one of the 5 strands of math proficiency, and that is conceptual understanding. Now, as I said, there are 5 strands, and I will leave a link in the description below to the video that talks about all 5 strands and where this comes from. But I want us to remember that these 5 strands are interrelated, interconnected. If your child might be really fantastic at procedures and answer getting techniques, that doesn't necessarily make them mathematically proficient according to this. They need to be proficient in all 5. So you may see things being done in the classrooms, in your child's classroom, that looks different from what you experienced in school. Or for some of you, it may be quite familiar. And you'll see why that's important for your child to do it. So as I said, in this video, we're going to look at conceptual understanding. Now, conceptual understanding is really knowing the why, how things are related, the meaning of operations. It's going beyond just symbol play to understanding what's going beyond the symbols and then looking for patterns. And as I said, describing relationships, coming up with rules without being told them because we notice the patterns and understand what's going on. So even if I look and say, think of 4, for many of us, the symbol 4 is what we think of. But for your children, we want to make sure they think of all the things linked to 4. It could be a 5 frame. You might see this in your child. And we're trying to help them understand what is it required, mathematically required when we use certain images, what is helpful and what's not required, what could even be misleading. So for example, with 4, I could turn this vertically with this 5 frame. I could turn it horizontally. I could turn it diagonally. It will not change the fact that the quantity shown there is 4. So we don't want to mislead children. So we're thinking of that with conceptual understanding. Part of it is for your child to again know, do I have to do that? Or is it helpful? Like commas in a really large number. Helpful, not required. It helps us read those numbers, define the periods, those groups of 3, but it's not mathematically required. Quite often on calculators, you don't enter the comma. So that's another key understanding for your child. And then I showed you 4 in one image, 7. Think of other places you see 7, like days of the week, or 12, a dozen, months of the year, hours in a day. So we want your child to go beyond just symbol naming to understand things it may represent, how we use it, and then think of images that are helpful. Here's that 5 frame image, and here I'm showing 7 as 2 more than 5, purposefully showing that. Here we use a 10 frame image. I see that 5 and 2 still, but I also see it as 3 fewer than 10. So you'll see images being used, helping to give meaning behind the symbols. And you'll see many images. It's not that one is more important than the other. It's the way that we can use them as we keep going. So I have shown you the 7. What if I do double 7? Now notice the one on the right is still 7. I just rearranged the ones on the outside. Not mathematically important, right? It's not required to put them in a certain location. Now, you see one image for double 7. This one, domino double. And we think of this because doubling is a really important idea for your first grade children to get, and then we're going to use it as they go right up through the grades. Doubling is actually a foundational idea and can use for this distributive property. These images, like the top ones, help us move your child away from counting by ones, but seeing the 5s and the 10s relationships. So we have double 7. I've shown you 3 different images. The first one gets us that doubling, and as I said, we'll get to distributive property. See double 7 as double 5 and double 2. Image 2 shows us a way to do it where it would be using a bridge to 10 strategy. And again, in the description below, I'll leave you linked to playlists that will give you more information on some of these terms and ideas that I'm using here. but that's a bridge to 10, and I'll actually show you more of that in this video. Okay, and then we can see the double 10 frame showing double 7 that way. And that way, I tend to see that as 6 fewer than 20. Gives me another option to see the relationships. This can extend to teen numbers. What's double 14? Double 10, double 4. Okay? But we are mindful, and we want to be mindful of what your child may be seeing and ask them, how are they thinking about the total? How are they getting it? How are they working and playing with the numbers? Is there another way you could find that answer? See, that's a way at home as you're working with children, you can help them develop those understandings. It's in some ways slowing down instead of trying to quickly get to the answer. That's how we're going to build those concepts. It extends then. Once we do that, see, think about 3 times 7. That usually is a difficult fact for children to learn, and we want to move them from just memorizing. If they know their facts, great, but again, we want them to understand what's behind the symbols. So I can read this as 3 groups of 7. Notice my image, and how can I think of that? 3 groups of 5 put together with 3 groups of 2. I can think of 7 as 5 and 2. Here is my distributive property again. Those images extend beyond grade 1 and 2. See, I can even use it when I multiply times a mixed number. What's 3 groups of 1.5? Well, it's 3 groups of 1 put together with 3 groups of 1.5. Now notice how I didn't use parentheses. In this case, they aren't required. They may be helpful for me to know which things I need to do first, but multiplication is done before addition, right? Order of operations. So again, we're getting into distributive property. Now, I mentioned the bridge to 10, and I just want to quickly show you that image. Here's that 8 and 6. See, what can I do? I can slide 2 over and fill that 10 frame. So 8 and 6, usually that's difficult for children to know. Same as 10 and 4, easy. Now, what is happening here is instead of associating those 2 with the 4 to get 6, I'm going to associate the 2 with the 8 to get 10. You see, this is the associative property. So if children know 8 plus 6 is 14, no hesitancy, fantastic. But this is the image that gets me the algebraic properties. Now, I can extend that. 99 and 18, see, I could fill that hole up there with one of the ones, same as 100 plus 17. No regrouping needed. I could do an image like this. Notice I've got 198 on the left. I've got 157 on the right. See, once I start to do this, I can use that associative property again. And you can see how I can break it up. I associate the 2 over. I'm doing bridge to 100, your child may hear in the young grades, but it's the associative property. It's the conceptual piece of associative property versus just what you see above. It's helping them have the image of what's going on, okay? Now, in this case, I might not use a bridge to 10 or a bridge to 100, the associative property, but I want to build the idea that we combine like size units. That's not so straightforward for some children. But see, if I think of 278 as 200 plus 70 plus 8, and 256 as 200 plus 50 plus 6, I have a really strong understanding of the size of units. I'm not just treating everything as ones place. That's important conceptually. And then I know I better combine hundreds with hundreds, tens with tens, and ones with ones. And you notice on the right-hand side of the screen, I've written it vertically. And you'll see the 400, the 120, the 14. I could have done it the other way, started with ones. And you'll hear partial sums. It's a place value technique. I'm using place value to add, and the direction in which I add will not matter because I'm preserving place value. So I'll get the same answer no matter the direction. That's important conceptually. Now, combining like units is a really important idea when it comes to computation leading up into algebra. And as I said, if I understand about combining like units, It won't matter where I write the numbers on the page. I can remember spending hours trying to get children to align everything. And when you line everything up, you're not focused on place value anymore. You're just worried about those digits in each column. But conceptually, we want to keep place value. So whether I write it horizontally, I write it vertically aligned, or I write it at this angle, I know that hundreds better go with hundreds and tens better go with tens and ones have to go with ones. And if I shift this to a decimal version, ones better go with ones and tenths with tenths and hundredths with hundredths. It will not matter where I write it on the page. So horizontally, vertically, anywhere on that page, I know I must combine like units. This is a really important concept. See, once I understand it for simple values, I extend it up to things like decimals. I can do it with fractions. That top line, what do I need to do to be able to combine 3/8 and 3/4? I better have the same size unit, right? So that's why we'll rethink of 3/4 as 6/8 so that we have the same size unit, that eighth piece. Once I know that, see, what can I do if I have 3 1/7 pieces and 5 1/7 pieces? How many do I have altogether? That's how I add the numerators and the denominator stays the same because that's the size piece I'm working with. And when your child gets to algebra, they'll hear combine like terms. See, when we think conceptually, we build that foundation from grade 1 in a way, right? When they get into double digit in grade 2, we start to build that idea so when they get to combine like terms in algebra, it's not new for them. It's an extension of what they already understand. Now, another way to help your child conceptually is when they see a story, have them draw a picture. So sometimes you'll see the teacher that will just give them the story, and that's the only thing they have to do is draw a picture. Sometimes we give them the picture and have them write a math story about it. Now, sometimes it's an actual scene. It could be a graph. You can see I have a simple one here that's I've used in kindergarten or used in grade 1, right? So in the early years, and the children have to write a story to match. And then you want them to understand there's lots of stories. I could write one using fruit, I could write one using toys, I could write one using animals, and that picture does not change. Or I could get a little bit more complex with the picture. See, we want to build understanding, and building understanding means we want to go both directions. So every once in a while, give your child a picture that you've drawn, something for them to tell you some math stories that go with that picture, and see how many different math stories they could come up with. We know that flexibility is key. It's key with procedural fluency. It's key in building that ability to deal with non-routine problems. Okay, so what conceptual understanding is telling us when it comes to math proficiency, it's about depth of understanding that's going to help your children excel at problem solving, especially when it comes to non-routine problems, and then not rely so much on paper and pencil when we could do things mentally and use some of those mental strategies, which are really algebraic properties. So 5 strands, we focused on conceptual understanding. Please check in the playlist to see some of the videos on the other strands that highlight those. I hope you found this helpful. If so, please give it a thumbs up. Again, consider subscribing to the channel. Click on the notifications bell. This year, I'll be posting every other week, but that notifications bell will let you know when a new video has become available. And as I said, thumbs up, notifications bell, share, consider subscribing. Thanks so much for watching.